Alright, welcome back. We got to take a little bit of a detour here. We got to talk about how to spec or choose a server. So one of the primary things that we're trying to get across, or at least I'm trying to get across, is that your network admin experience is very different than what it would be 20 years ago. So you're going to be expected to know server hardware. You're going to be expected to know how to set up a database environment. You're going to be expected to know quite a bit of knowledge. And part of the reason why that is because technology in general seems to be uh, consolidating, essentially. For the most part, businesses view your service as overhead and not necessarily essential for the product. There are a few conditions out there where that might be true, or that might not be true, but in terms of a network admin, for the most part, you are considered overhead. So the more value that you can provide the company in terms of skill set, the better chance that you have at being successful in your career. And this is one of those things where traditionally you would not have had to know a whole lot about server hardware. You just pick something that someone else would have done for you, like a system architect, and then you would have been just install the server and do what you have to do. Unfortunately, that doesn't seem to be true anymore. So let's go over this presentation, and hopefully it makes a little bit more sense of what the procedure should be, or at least close to be, when you're trying to select a server for a particular use case. So the first thing that we're going to do is set up a condition where we can actually talk about something a little bit more precise. So we're going to talk about a resolve file server. So at the moment, I want you to think about what file servers actually are and how you are going to accomplish that if it was just files. Okay, so if it was just files, you don't necessarily need something that is particularly big. Your latency isn't a huge issue depending on the files that you're trying to give. And then in terms of caching, again, I don't think it would be a very big deal. However, being that it's a video editing server for files, that changes quite a bit. So what ends up happening typically when someone comes to you and says, we need a new server, we need new hardware, we need a new solution, it typically sounds something like this, where we're unhappy with something about the performance, something is hurting our workflow, something is wrong. So here's the condition that I'm going to present. Your company or whoever came to you is unhappy about the speed of scrubbing for their editors. Okay, so that's a condition. They have been experiencing runaway footage. So what runaway footage is when you hit stop or play, mostly stop, is, okay, we're playing this clip, okay, I want to make a cut here, I'm going to hit stop, and then it keeps going because the latency is so high that once the software actually gets that message, or the CPU gets that message, it thinks it was much later than what it actually was, or when you actually clicked it on the interface. So that's a latency problem. It's typically a disk problem. Occasionally it can be a CPU problem. If you have the ability to go find out which type of problem that is, it'd be best to do so. But for the sake of this presentation, it doesn't overly matter because we're going to solve that problem regardless of what it is. So, and the next condition that they have is that they're only going to store final videos, final renders. So you don't necessarily need the raw footage, which is going to help out quite a bit because a lot of companies out there, they store raw file types, which are huge. After it's rendered, after it's compressed, after it's H.264, it's significantly smaller. So your storage requirements isn't going to be nearly as much. So let's continue on a bit. So unstated factors, this is when we have to talk about, okay, the people that are going to come to you don't necessarily have a solution for you. They're not going to bring you what they want, essentially. They're going to tell you what the problems are, and then it's going to be your job to solve those problems. So one of the things that we need to consider is, okay, there are assumptions that are built in for a good solution. And it's going to depend on your reputation as well to actually understand what the unstated factors are. So, local redundancy. When we're talking about a company that is with videos, more than likely they're going to want to keep those videos around. So if we're assuming a YouTube company, then yeah, they're going to need to keep those YouTube videos around just in case they need them for other video clips later on, or something legal perhaps, or they need to be able to have those videos on hand. So redundancy is going to be important. How you solve that redundancy typically is done through software RAID these days, which we'll talk about the solution here towards the end of the presentation. But this is one of the things that it's just understood that reliability has to be built into the system. Okay, network redundancy to the server. Okay, the multiple switches at this point. So if you have a single point of failure on your system for a company, even relatively small like this one, but because they're in such a time crunch and YouTube is relentless on the algorithm itself, so your scheduling and your release date has to be very consistent. So they can't necessarily go down for even a few hours if something fails. So switch redundancy is going to be important here. We're going to focus on the server today, but this is something that you need to keep in mind as well if you're going to provide a full solution. But we're going to focus on the server today. Okay, company's YouTube channel shooting with a Sony Alpha 5100, and they plan on upgrading soon. So what this has baked in is, okay, we know what the specs are of each camera. We have to go find those specs. Those specs are out there. Obviously Sony is going to have them, but if you're going to make a server based on storage, right, because storage is going to be your primary limitation here, or primary consideration, you need to be able to go, oh wow, you're using this camera, let's go figure out what it can actually produce in terms of file sizes, or just in general, what can we expect based on the devices that we're using. Okay, same thing with the Sony A7S III, right? It's going to have its own spec sheet. It's going to be one of those things where, okay, we have a general idea of what this camera is capable of. The next question is okay, how are they actually going to use this camera? Are they going to turn down the bit rate quite a bit? They're going to have really, really long videos. What else do we have to consider, right? Just knowing what the camera can do doesn't necessarily mean you know everything that you need to know. So with that in mind, there are 10 editors, which will be important later, and then 15-minute videos, right? It's your standard YouTube video at this point, okay? So keep that in mind for a solution later, and we're going to need that. So the first questions you should be asking yourself, and possibly the people that came to you, is what's the use case? What are they using it for? What do we need in terms of the server? And then how is the software going to interact with that hardware? So this is a really important concept, because you can't necessarily just throw money at a problem. So if you had a blank check, then yeah, the solution is buy the best hardware possible and then you'll be fine. You're not going to have that ever. Bang for buck matters, optimizations matter, and you're going to need to be able to essentially go, okay, we need this performance here, and then we can cut back over here. Okay. Next question is, how many people are going to be using the server? The use case that I presented here a few seconds ago was 10 editors, right? And if it's a resolve file servers, then we got 10 users for the most part. They're actually going to use it for what we intended to. So even if other people are using it for like a general file server, the workload on that is very, very small. So you don't have to worry about it, really. How does the software use the hardware? As I was just saying, if we're talking about resolve, then we have to be really worried about latency. So we need some sort of caching system, and then we need to make sure that our storage is actually big enough for what they're expecting out of the server for them to feel like it's worth the investment. So that leads me well into the next point here, are the conditions that need to be met that are not relative to the use case. So basically what that means is, okay, the use case, we're talking about how are people going to use this on a day-to-day basis. And like what I was saying before, typically your company is not going to invest in something if they don't feel like it's worth the investment. So for this company, we're going to assume that they want to have this server last for 5 years. And what that means to them is, let's make sure that the storage lasts for 5 years, that we're not going to run out of storage anytime soon. Okay, we can do that. And then use the server. The use of the server could change based on what the company is trying to do. So if the company grows and they get to a point where maybe they want to start running VMs, maybe thin clients, a hypervisor, that type of thing, we need to be able to have the hardware capability to do that. And that's going to determine our selection here shortly as we progress through this presentation. But the hardware that was selected for this doesn't necessarily make sense if we know that this file server for resolve editing is just what it's going to be used for. If that was the case, I'd make different choices. But with that said, we have to keep these in mind. If the use cases, or if the customer wants you, or your employer for that matter, wants you to create flexibility within the hardware, then you need to select hardware that is flexible. Okay, server needs to handle growth of clients or internal users. Okay, and then the server needs to have 24/7 availability. Again, back to what we were talking about before with, okay, timing is a big problem. So even 6 hours of downtime is going to be a real issue. Okay, so again, and there might be more questions that you have to ask depending on what you're trying to accomplish and what the problem actually is that you're trying to solve. Okay, so determine known knowledge. So at this point, this is where you go, okay, here are all the things that I understand about the software that we're talking about. Here are all the things that I understand about the server hardware that is currently on the market. So the reason why we do this is because if you're in a time crunch, there are assumptions that you can make about software that you don't necessarily have to go and confirm. And the example that I give here is Blender Viewport is rendered by the GPU and not the CPU. And that's probably not going to change anytime soon. Those are the things that you don't have to go test. Same thing with network latency. So if you're going over the network, if you're going from computer to switch to another computer, and then that data has to go back from that computer to a switch to the original computer, there's going to be latency involved with that. So in general, right, if you're hyper concerned about latency and it's that important, then you want to have that data as close as possible to the CPU that would be processing it. In this case, it's not that sensitive, but latency off of drives is probably going to be a little bit too much. So we definitely need a caching system. So let's move on. Okay, research the unknown. Once you understand your known knowns, you need to research your known unknowns. So this is going to be all the things that you need to double check on and make sure that, yes, AMD performance on their server platform is par or better than Intel's. Yes, the drivers might be the same or different. Yes, Intel might be a little bit different. Or say 10 years from now, we'll be using ARM server CPUs, which is a possibility. Then that's something that you're going to have to go research and go, okay, is it worth switching to ARM? Is there any problems with that? Software, okay, do we want to use something like a TrueNAS Scale or TrueNAS Core, or do we just want to go pure Debian and use OpenZFS and do it ourselves, right? This is where you have to go, okay, what don't I know? What do I need to make sure that I'm sure on at this point? And then I have extrapolate here in orange. So the reason why I have this here is because you're not going to get full solution answers. You're going to get pieces to the puzzle, and once you get those pieces to the puzzle, you can extrapolate from there. So the logic essentially goes something like this, where it's, if this is true, something over here must be true as well. And then if you're not sure if that is right, go test it. And then that test should tell you, okay, was it right? Okay, cool. If it was right, then you understand the problem. If it was wrong, then it's a paradox and you need to dig into that problem a little bit more, time permitting, of course. Okay? So, moving on. So, in terms of the file server itself, as I have already mentioned, lower latency is going to be a little bit better for video scrubbing. Okay? So, basically what we're trying to do is whatever file that this person is working on for the editor, we need to make sure it's not on a disk. So one of the things that people get confused about quite a bit when it comes to performance of disk is latency versus throughput. So NVMe drives are known for their throughput, essentially, but they're actually significantly better with latency as well, even compared to your SATA 3 SSD counterparts. So your NVMe drive is going to have better latency just because it's connected directly to the CPU if you have the correct wiring for that. A SATA disk, on the other hand, a spinning platter, is going to have a significantly higher latency, and this is part of the reason why this customer probably had a issue with runaway footage when they hit stop and the video kept playing. That's probably a disk latency problem. The other problem with having high latency on your disk is because when you have a set of operations that you need to accomplish, okay, well, you have that latency penalty every single time that you need to do that operation. Caching on disk batches operations, of course, but even with that optimization, it's still a problem. Okay, so ingest rendered footage will be resource intensive. So what we mean by this is if you have 100 gigs that you're trying to send to the server all at once, you're going to fill up your RAM cache unless you have enough RAM for it. And then if you don't have enough RAM cache, you're essentially going directly to the disk, just because of how my solution is TrueNAS, just because of how TrueNAS works. It doesn't go RAM cache and then the NVMe drive for writing cache and then the disk. It goes RAM cache and then straight to the disk once it runs out of space. So that's something that we need to consider, if we also know that the file size limit is probably going to be around 100 gigs, then we can account for that, and we can definitely get a RAM cache that's big enough to ingest a video and then have that write the video on a later time. So file caching is important here, optimizations are important here, understanding what the use case actually is going to be important here, especially if you're trying to do this on a budget and be very precise about what you're trying to do. So let's continue. Software orientation, DaVinci Resolve, video editing software, client-side intensive for the most part. Okay, so if you're running a file where you're trying to get a file off of this file server, most of the processing is going to be on the client, not on the server. Okay. Okay, our server needs to provide video footage fast enough so there are no issues. Okay, so again, this is a latency problem. So we are incurring a little bit of a latency issue with the network. However, if it's just from a computer to a switch to the server, if we have that on an NVMe drive, we should be fine, okay? Server software needs to have ZFS or a Btrfs. We're going to use ZFS here for our solution. Debian 11 will work if you want to do it yourself, or TrueNAS Core is what I have selected to do here. And then the other thing is if you're going to use a Windows server, you're going to need Robocopy for the client, for Windows client, and RDMA, which is Remote Direct Memory Access, and it bypasses the TCP IP for faster file transfer. We don't have to worry about that, but if you're doing a pure Windows environment, you need to be aware of these things. Usable storage here is going to be 188 terabytes. So even if they swapped out cameras today, we'd have enough storage. So this gives us enough leeway for whenever they change over cameras, or if they get to that 5-year point and they're at a bad time to essentially take in another server so they can have more storage, you don't have to worry about it so much. They get a little bit of leeway, and then you have plenty of warning too once that storage pool starts to get more full. So okay, network needs, as we're talking about, 125 megabytes is max throughput in theory for 1 gigabit switch. I typically get 113. There's overhead there, so one Iron Wolf will saturate a gigabit link. Okay, so 10 gigabits is 1,000. So if you want to take advantage of the true read and write throughput of your disk and your RAM cache, obviously you're going to need something a little bit more than 10 gigabits, but this is where we have to start talking about it isn't necessary, because there's a significant price increase when you start talking about 40 or 50 or even 100 gigabit links. So that's one you're going to have to communicate with your customer or company about what is actually worth it. Okay, so 10 gigabits is a good compromise here at a minute 0.3, so a minute and 20 seconds ish for 100 gigabyte transfer, which is what we're trying to target. Latency is the primary issue here, and RAM cache will be used. So yeah, this is one where you probably want to make that compromise where there's not a huge difference. But if your company is, well, no, we paid for this performance, we want to make sure that we get it, they're going to need the switch as well. So here's that. Let's go over the CPU. It's not very CPU intensive for the TrueNAS Core, at least. If you start doing a VM server because you have that server there, that changes entirely where you're going to need those threads. Okay. Cores are helpful when multiple people are accessing your NAS server, yeah, which is true. And then checking parity as well. Multiple cores is helpful. PCIe lanes are helpful for future upgrades if the use case ever changes. Okay, RAM. Performance here in terms of your latency, what we would consider cache latency and the other latencies as well, is not necessarily helpful. ECC is definitely helpful here if you need it. RAM cache for video, not super practical, just because of how expensive RAM is. But RAM cache in terms of reading in and ingesting footage is something that we should probably use here. And then we're going to target 64 gigs if you want to do some arc tuning as well. So platform, Threadripper Pro, so is one step under your EPYC lineup. Pretty good compromise here as well. You're not really giving up a whole lot. You still get ACC RAM, you still get your threads, you still get your power output, and you still get your headless boot and IPMI as well. So not a whole lot of reason to go EPYC here unless you're doing a massive scale database or a massive VM server. So first draft, let's pull this up. Okay, so here's our case, Newegg Business. Here's our 24 drives, hot swap. If anything happens to it, you just pull the drive out, put a new one in, and the parity is going to fix itself on your TrueNAS Core. And then for the server itself, we have our power supply here, 1300 watts. Super overkill for what we're trying to do here, but if the use case ever changes, we have the overhead fans, okay, drives, makes sense. Registered RAM, take a lot of that memory controller stress off of the CPU and put it on the RAM itself. And doesn't come at a massive penalty for in terms of price. Threadripper Pro, we did basically the lowest tier here. We don't need anything real intensive, so 16 core, 32 thread is going to be fine. Here is obviously data stock now, but here would be your caching drive and NAS SSD. Gives you that latency. You don't necessarily need throughput here. And this is probably the controversial point of this little rough draft here. Because we're using a 4U server, we don't necessarily have the size in terms of height to get a big tower cooler in there to cool Threadripper. So we're going to have to use an AIO, which is generally frowned upon for server environment. But again, we're trying to do bang for buck here. So this is a pretty good compromise, and then you don't have a whole lot of options for your motherboards for Threadripper Pro. So this is what we got that still has IPMI, and that price came out to be about 10 grand. So if they can't afford that, you can make some other compromises somewhere else where you can go down to the consumer line, and then you're going to sacrifice a little bit on the RAM front, just because you're not going to have ECC RAM. But again, that's another good compromise if you're relatively certain that this is going to be a file server and nothing else. So yeah, there's that. So hopefully that made sense. So one of the closing things that I'm going to leave off with is if you have the opportunity to actually test the software with software with a hardware combination. So if I pull up my browser again and I come over here to TrueNAS Core, this is my TrueNAS Core, and this is what I use at home. So the best thing you could possibly do is get a little test going with the software that you plan on using, having a little test server, and then going, okay, what are the metrics that we're actually looking at? So something like over here, we're really concerned about latency here. So let's go find some latency, and right here's some latency. Okay, so ADA is going to be the SATA. So my SATA drives, I have 4 terabyte drives. So we have 6 of these. So read, okay. Min max, again, this is latency, a max of 15. What is the... Okay, let's go over here. Okay, yeah, so the time is in milliseconds over here. 15 milliseconds is a long time for a disk, okay? And I've seen this as high as 50 milliseconds, depending on how busy the disk is, if it's writing something in particular. It can get really high. So there's that. If we go down to our latency for NVMe drive, which is NVD in this case, milliseconds latency, highest is 0.6. So significantly faster in terms of latency. And then if we're talking about disk operations, we actually need some throughput. Okay, request IO. IO operations is really important as well. So if we come over here, 0.8, okay, the highest was 2.6, so request, I'm assuming this is going to be per millisecond. Yeah, so let's come down here, let's go find our NVMe drive. Here it is. And this one is 0.8 as well, so that's interesting. So we really need to test this to see what we get out of it. Maybe I'll do a Crystal Disk Mark and I'll append to the end of this what those results are if I can actually get that to work. So with that said, hopefully this helped in terms of how you should be thinking about speccing out servers, and then your needs assessment needs to be a formal, essentially just process of exactly what we talked about here, of going through the questions. What are we trying to solve? What are the conditions? What are the assumptions? What exactly are we trying to solve? That's what it comes down to. And then you have to write that needs assessment in a way that is, one, technical. It's targeted at the right audience as well. But if someone replaces you, someone comes after your time, they need to be able to read it and go, okay, this is why they did what they did. Okay. With that said, I am going to sign off for this one. Again, hopefully this was helpful, and I will see you in the next one.